It is a great pleasure to invite you for this webinar. So, as rightly mentioned, you have a vast experience in the additive manufacturing space. So you have been running one of the most successful service bureaus around the globe.
It's been a very exciting journey. I've maintained a high level of excitement about potential for additive manufacturing, and it's always a pleasure to be able to talk to people about how they can make the most of the technology. Most of my most recent experience really running 3T. I'll go on to the main part of my presentation, I think, to go into the main body of what I'm doing. So, just some thoughts on the topic relating to buying parts, and I'm really assuming that these comments relate to most people, but particularly to less experienced users. It's most important to understand the additive manufacturing benefits before you really get into buying parts and procuring parts from suppliers. And that process starts with educating yourself by perhaps going to shows or seminars or whatever. And your objective overall is to be what could be referred to as a smart customer. So you're not just going in there and everything's rather dazzling when you talk to your supplier. You can go in there with some confidence, which is something that I certainly find helpful when I'm buying a new whatever it might be. So understand the benefits, but also understand the drawbacks of additive manufacturing, because there are plenty of drawbacks, but you can get around most of them if you choose. Right. So choosing the right parts. This is really very, very important to make sure that you're choosing the right parts. So the best bits typically have multiple benefits that you can gain. So mass saving, speed of manufacture, improvements in performance and so on, as per the diagram that Ankit showed earlier. Equally, the wrong parts can give you a fair bit of pain. So if you determinedly go ahead and choose a part which really isn't well suited to AM, it'll possibly cause you failures down the line, be more expensive, not prove the technology, and might even set you back years. I've seen cases where customers have done that. It's a painful process to get back. The key part within that is taking your time and goes painstakingly from 1 to 10, as it were. So rather than 1, 2, 3, 10, if you jump steps, then typically your risk goes up. So this is something that David Wimpany mentioned in the last seminar. Then you go on to choosing the right technologies for the parts, and it's a natural follow-on really from understanding the benefits. So not all processes are made equal from the point of view of the component, and you just need to decide based on benefits which is the right process for you. And Ankit's just gone through some of that. But for example, powder bed is excellent for high detail, high resolution, or complexity, small holes and channels. But a blown powder type process might be best suited to rapid deposition and very large parts, but not be any good for holes and channels. So that really goes then hand in hand with choosing the right supplier. Now, a good supplier will help you through the process. They may have a single technology, and if it's not suited to what you want, then they'll tell you and say, well, look, we think the right technology is a different one, it's X, Y, Z, and if you've got something that suits us, then great. But if it's the right one, then fantastic. They'll have a high level of technical competence. They'll be able to assist with the design for additive manufacturing. They'll be easy to deal with. They have a complete process chain, most likely, and they'll have an excellent reputation for quality and quality standards. Mind you, the best supplier may not be the cheapest, of course, but in the long run, they probably will end up being the cheapest overall. So moving on to design for AM. So any part you choose, you can almost certainly reduce the mass or improve the build time, improve the performance by designing for taking advantage of additive manufacturing. and you can probably also combine parts together.
Mhm.
Finally, once you've done all of that, then the important thing is to review what you've done, learn from it, and then move on, so that you can multiply the benefits through your business, and that then can give you the opportunity to look at the final point, which is working towards system level design for additive manufacturing. So GE are probably the global leader for metal AM use. That is what they do. They look at the whole system and treat additive manufacturing as just one of the many processes that you have available for manufacturing. So those are my key points. I hope that's been helpful.
Thank you, Dr. Ian. In your experience, how have you seen the transition of a customer and his or her adoption of the technology itself in the course of your career itself? So can you just throw some light of your customers' evolution?
Yeah, sure. Thank you. Pretty much everybody goes through the same basic steps, whether it's additive manufacturing uptake or any other technology. To begin with, and in fact, you can see some of this if you look at the Gartner hype curve. It gives you a rough idea. But initially, you're exploring the technology, and at that phase, it may well be amazing. It can do everything. It's going to solve all the problems, which, of course, no technology ever does. It may solve some, but creates other problems. And then you go through a series of stages of gradual uptake, where you might just try getting a part made, and then that's where some of the points are made about purchasing, and were just made now about purchasing behaviour are very important, just to take it a step at a time. And then you go through and perhaps have a company strategy. You may even have an in-house team for additive manufacturing, which is then very helpful to the supplier, because that in-house team does the hard work internally. Hopefully they're knowledgeable and keen, which they usually are. And then eventually you go through to production, if that's what your goal is. And then, of course, GE is the ultimate example of systems integration and systems design thinking. In terms of success, those that succeed are generally a bit more cautious than those that don't. Those that don't hype it up internally are more successful, and those that follow the steps 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, perhaps a little boring, a little bit unexciting, but in the end it's a lot faster to go a bit slower.
And as Dr. Ian is coming from UK, and I think one of the most experienced people in UK, and last year itself, I think one of the biggest sporting day in the global history, the Wimbledon, the World Cup final, and the Formula One. So I would like to ask you, as you are placed uniquely with the Formula One companies in the UK, and you see a lot of Formula One users, and the technology has been adopted really well with the Formula One teams. So how do you shrink the time, increase the part quality, and increase the reliability of the component? How have you faced these questions with your customers, Dr. Ian?
I think one of the really key points is the one that Arthur was making regarding partnership with the supplier. So everybody can gain by getting the supplier involved very early in the design and development process. So although you're actually involved with the whole project for quite a long time, when it comes to the point where the part is really needed, you've done all of the hard work, you've designed for the process, you've tested out the difficult areas for building the part, and maybe built sections of the part, and then when it's really needed, you can get on with it. Now, the Formula One teams started with relatively simple parts, and in fact the best benefits they got, certainly even until relatively recently, are largely exhaust parts, but they gradually moved through In fact, I think the first parts, some of the first really critical parts were roll hoops. And the simple roll hoops worked really well. The complex ones were a nightmare to build. But yeah, I would say the key thing is partnership between the service provider and the design team is absolutely essential. So just echoing what I said earlier.
How was turnaround time being so crucial, and how was 3T answering those questions?
The turnaround time?
Yes.
So why was it critical, did you say, or in what way, what did we do to reduce it? Which was the question, sorry?
Exactly. What way were you able to reduce it?
Well, reducing the lead time, as I say, the design process tends to be measured in weeks and months, but the bit that matters is that the design is available at the right point, and that both the supplier and the design team and the customer know exactly what is required from that in terms of quality standards, finishing processes. So as with anything, the best way to be really fast is to be proactive and make sure you've designed out the niggly areas that are going to cause variability. Roll hoops are a fantastic example. Some of the roll hoops that 3T made many years ago were just the most awful things to try and build. And in fact, in one case, the roll hoop was 1 unit of mass, and the support structure trying to stop the roll hoop from ripping itself to pieces was 1.5 times. So the supports were heavier, greater mass of material than the roll hoop. And that's all down to design. If you design with AM in mind, you can be really fast.
So
does that answer your question?
Yes. So on your level, like, how do you see the adoption from the industry if you go from top to bottom? So the automotive, the aerospace, the medical, because you have experience with all of them. So how have you seen the questions changing, the profiling changing of the customers, and how do you see what kind of industry has been adopting really well?
So you're talking about industries or within each company? So there's two different approaches.
Sector. Yes. Sectors.
Okay, so yeah, in terms of industry sectors, probably aerospace were the very earliest of the major adopters, from the point of view of metal anyway. Personally, I was in automotive and we were using stereolithography. I commissioned the very first stereolithography part in 1989 for Rover Group. That was done on I think it was a SLA 190 or something. It was a tiny machine, and even that part, which was only maybe 250 millimeters, was made up in 4 pieces of very brittle stereolithography resin. So aerospace were very advanced, but they've got an incredibly long take-up curve. Interestingly, Formula One were very advanced. They all did polymer first, and aerospace moved into metal in very different ways between, say, GE and some of the UK and other manufacturers. But it's like anything. You don't see the gestation period. The gestation period can be maybe 2 decades, and then suddenly it springs up. So I think bamboo is the classic, where it can lie dormant. I think it's bamboo, correct me if I'm wrong. It lie dormant for a very long time, maybe years, but then when it does grow, it can go very fast. And that's fairly typical. So automotive is really up and coming, but the cost is a major barrier. But there are quite a lot of parts running around on relatively small going road cars, particularly supercars, hypercars. And then medical was quite an early adopter, but they tended to take it all in-house to a very large extent, with the exception of the acetabular cups, where Arcam technology was very popular because of its speed. And industrial applications, I think, is where it's very exciting. And at one point I would like to make is don't be afraid to take on boring parts. So the boring bits are actually very often the most exciting. So my classic example is brackets. Yes. There's loads and loads and loads of brackets. Jigs and fixtures, David Wimpany mentioned in the last seminar. Brackets, jigs and fixtures, they're not sexy, they're not exciting to look at, but my goodness, you can get huge benefits by using additive, plastic and metal by going down that route.
So the mundanes, you're saying try to work on the mundanes and the non-sexy part of the AM side, right?
Don't be afraid to go for the mundane, because that in the end it may be that the mundane bits turn out to be the superstars. I'm not saying that is always the case. Obviously, the sexy bits can also be fantastic. So turbochargers for Formula One cars, incredibly difficult to make, very sexy, awesome parts, and very successful. But don't turn away from the slightly duller parts.
Exactly.